Okay, so it's just a quick video on finding angles between two lines. Okay, so suppose we have two lines. Maybe the first one is a plus lambda m. Okay, so this could be r. Okay, equals to a1 plus lambda m1. Right, when you have a1 as a position vector, you have another line here. Right, this probably r equals to a2 plus lambda m2. And lambda, sorry, this is not lambda, let's call it mu instead, right? Let's call this mu, right? Where lambda and mu are real numbers, okay? And then you can observe that, recall from earlier on vectors part 1, we studied that if we were to talk about finding angles between two vectors, a and b, where in b, right, then our vectors here, the angle between the two vectors is just cos theta, right, which is equals to a dot b mod a mod b. Right, so this similarly just appeals to the same as the angle between two lines, where instead of a and b, we uses the direction vector. And here we can see that if we were to take the direction vector of line 1, for example, let's say I just call this line 1, right, and I call this line 2, right, then the direction vector of line 1, this is just m1, right, direction vector of line 2, this is m2, right. So for us to find the angle between these two lines, it's the same as us taking the angle here, okay, between the two direction vectors, right. So very quickly we can say that, you know, if you want to find theta, cos theta will just be equals to m1 dot m2 or m1 or m2, alright. And here we are always talking about the acute angle, alright. So we always assume this theta to be acute unless otherwise stated. So it means that our cosine theta has to be positive, alright, because if this theta is not acute, then cosine theta will be negative. So here we always assume theta to be acute, right, unless otherwise stated, right? Because we are always I mean, there are a lot of ways to look at the angle between the two. It can also be this one, right? Okay, but in this case we are just looking at the acute angle, alright, otherwise stated.